Okay, this section 6.5 is going to discuss a couple of factoring techniques for polynomials. Now remember, quadratics are polynomials, and we've already discussed factoring techniques for quadratics. So these are going to be factoring techniques for things that aren't quadratics. So like cubics, maybe something with 4 terms, because we know how to factor a quadratic with 3 terms, but we haven't talked about how to factor one with 4 terms, as an example. So that's not really a quadratic, that'd be a cubic. Anyway, so we're going to talk about 2 techniques today, and then a couple techniques on Monday. That's 6.6. The 2 techniques today are sum and difference of cubes, and then factoring by grouping. Okay, sum and difference of cubes is on the wall, right over here. It says sum of 2 cubes, difference of 2 cubes, and it'll stay up there for you to use. Okay, now the way you recognize the sum of 2 cubes, it's just what you think. If I have x cubed plus 27, I have to know my cubes for you to understand this system. So we know that this is the cube of 3, right? Because 3 times 3 is 9, times 3 is 27. So you're going to need to, you've kind of got your squares down, I hope by now, up to 8, 9, 10, right? 1, 4, 16, and so on. 9 and 16 and so on. Cubes. So we have 1. What's the cube of 2?
4.
Cube of 2.
8.
8.
3 is cube, sorry.
Yep. 1. 8. What's the cube of 3? 27. Cube of 4?
30.
Cube of 5?
145.
Yep. Cube of 6? 36 times 6?
298.
216, I think. Someone do it.
That's like 190.
190.
190 each.
216 times 6. 196?
36 times
36 times 6.
216.
216.
Okay, you kind of get where I'm going. Okay, you're probably not going to see using the difference of 2 cubes for a numbers greater than 5 cubed. Okay, so if you know the first 5, you're going to be in a good place. Okay, so what you've got to do first is recognize that both terms are perfect cube for this to work.
Right.
Okay, once you do, what you're going to do is take the cube root of both.
Okay.
Cube root of x cubed is x.
B equals 5.
Cube root of 27 is 3. Now, I'm going to look at the poster. I've identified A, I've identified B.
Now we just plug it in.
So I'm going to say A plus B is x plus 3. A squared is x squared. This sign is always opposite this one. These 2 times each other. And then this one squared. That's how it factors.
A3 plus B3.
A cubed plus B cubed factors this way.
Okay.
I found A and B. In my case, it was x and 3. I plugged it in. A plus B is the first parenthesis, x plus 3. A squared is x squared, minus AB minus 3x, plus B squared, which is 9.
So now we solve.
Now you're done.
Oh.
Okay, if I wanted to solve, I could. The first, I know x is negative 3. Right? How could I solve this? I'll tell you right now, it will never be factorable. Never be factorable.
Usually like that.
So quadratic formula, if I were solving, I'd have to use quadratic formula on that. Okay? And most of the time, if not all the time, these 2 answers will be imaginary. So you'll have 1 real and 2 imaginary for the ones that you can do sum and difference of 2 cubes. Okay, let's try. I'll let you guys try one real quick. I don't want to do 64. Let's do 8x cubed minus 125.
Okay, yeah.
So 2x,
minus 5.
what's b?
5.
Okay, so I have 2x minus 5. What is a squared?
A
4x squared.
4x squared. Be careful. Don't tell me it's 2x squared. You've got to square the 4 also. Plus, this sign's always the opposite of this one. The two times each other. Plus b squared.
That's it.
Yep. And I can't factor. It looks like I could try the perfect square binomial because these ends are squares. So if I tried that, it would be 2x plus 5 times 2x plus 5, right? But how do I check the middle term? This times 2. This would have to be 20x for this to work, and it's not. So this does not factor. So I'd have to solve it using the quadratic. Okay, so that's how it factors. Questions on difference and sum of two cubes. This works. This is a special factoring. We did a difference of two squares in the quadratic chapter, right? X squared minus 16, x squared minus 25, the difference of two squares. This is the sum and difference of two cubes. Okay. The last, in this section, the last thing we'll talk about is something called factoring by grouping. And for factoring by grouping to work, there must be 4 terms. If you have a quiz and you see a problem that says, solve this by factoring, okay, and then you look and there are 4 terms, there should be something that goes off in your head, some alarm that says, I need to use factoring by grouping. 4 terms, factor by grouping. Okay, this is how it works. It's kind of factoring inside of factoring. I'll just do one here.
This is the difference, right?
Huh?
This is different.
This is factor by grouping. I'm on a different strategy now. Factor by grouping is when you have 4 terms. Okay? Difference in sum of cubes, there's 2 terms. Right? Factor by grouping, 4 terms. Okay? What you're going to do is you're going to look at the first 2 alone and look at the second 2 alone. So looking at the first 2, what's common to both?
X
6
X
x
squared.
cubed.
cubed. When I factor an x cubed out of this, what's left?
X.
2x. When I factor an x cubed out of this, what's left? Minus 3. So I've handled the first 2 terms. Now I'm going to focus on the next 2 terms.
Okay.
Okay, what's common to both? This one didn't give me a good example. I don't know what this problem is. 2x to the 4th minus 3x cubed minus 16x plus. Let's try that.
Oh, 4.
Okay, 4. So if I do plus 4,
X.
when I pull this out,
Negative 4.
negative 4x, it's actually 8, isn't it?
No. 4 times 4.
Isn't 8 a factor of both?
Oh, yeah.
Yeah, but so is 4.
But 8's the biggest. You always do the GCF, the greatest.
Oh, okay.
So this becomes
2.
negative 2 plus 3, right? For factoring by grouping to work, this parenthesis and this parenthesis must match. Do they?
No. No, they don't.
This one's positive, this one's negative.
Right. So they don't.
So how can I make it match?
Times it by negative.
Right? Is negative 8 times 2x negative 16x?
Yes.
Is negative 8 times negative 3 positive 24?
Yes.
Yes. Okay? So my parentheses match now. So what I'm going to do to finish this problem is I'm going to do one more set of factoring where I'm pulling out what's common to both of these terms. Or this is a term, this is a term. What's common to both?
An 8.
2x minus 3.
Oh, yeah.
Do you see that?
Yeah.
Don't do this to me. 2x minus 3. I'm going to pull that out of this term, and what do I have left? and I'm going to pull it out of this term. What do I have left?
Sweet.
And now I can look at this. What is this? Difference of
Difference of
cubes. So I can factor this. 2x minus 2, x squared plus 2x plus 4. And then I still have this 2x minus 3. So I just completely factored this expression. Okay? Factor by grouping works with 4 terms. 1, 2, 3, 4. You concentrate on the first 2, get that factored by what's common to those 2. Concentrate on the second 2, get that factored on what's common to both. It only works when what's common to both is the same. So if you have a negative sign, pull it out so you can get them, force them to be the same, like we did. Then you're going to factor what's common to both of these terms out. And what's left is x cubed minus 8. Then I went on and did a difference of cubes.
And you just brought the 2x minus 3 down.
Yep. Okay, factoring techniques for things that aren't quadratics. Sum and difference of cubes, and factor by grouping. Factor by grouping is 4 terms. You want to try one more by grouping?
Yeah.
Okay. (15x to the third) plus 6x squared minus 10x minus 4. Okay,
So
focus on the first 2.
3.
3,
X squared.
good.
So taking 5x plus 2.
How much
2.
is it?
So
5x.
negative 5x minus 2. Hey, we need to switch the sign of the 2 so that will be positive.
Does that make sense so far?
Yeah.
Okay, now what's common to both of these terms?
5x plus 2.
And what's left when I pull 5x out of plus 2 out of this?
3x squared minus 2.
And now I can't factor any further. This is not a difference of squares.
Nope.
So I'm done. Okay, the reason we do this is if I've got, we're going to learn in this chapter how to graph this function. Okay, and one of the components of graphing a function is finding its zeros. Right? In quadratics, how do we find the zeros? We set the quadratic equal to 0. Okay, here I'm going to do the same thing. I'm going to set this equal to 0. But I have no idea what I'm doing yet with this. This is something I've never seen. If I can factor it to this, actually this one to this, and set it equal to 0, I can solve this. I set this equal to 0. 5x plus 2 equals 0, or 3x squared minus 2 equals 0. So I've got negative 2/5 is 1, 0. Over here I have 3x squared equals 2. X squared equals 2/3. X equals plus or minus the square root of 2/3, which is going to be a decimal. But I have 1, 2, 3 zeros. So now I know where this graph crosses the x-axis. Plus or minus 2/3. Okay, so this is why we are learning these factoring techniques, so that we can solve polynomial functions and graph them. Okay. All right, I'm going to stop here and then start it again and go through the quiz.